Welcome to my projectbazaar.com.
Now let us discuss about the some throughput maximization for multi-user MIMO cognitive wireless power communication networks. Let us discuss about the abstract of the product. So the multiple antennas in MIMO systems can be explored in two different ways. So one is the creation of a highly effective antenna diversity system, and then the other is the use of multiple antennas for the transmission of several parallel data streams to increase the capacity of a system. So the antenna diversity is used in wireless systems to compact the effects of fading if multiple independent copies of the same signal are available. So combine them to a total signal with high quality even if some of the copies exhibit the low quality of the process. So here we using in this proposed work wireless power communication network, so that is called a WPCN, by using the MIMO concept, so multiple input and multiple output concept, in which the secondary WPCN SAR with the primary wireless information transfer the system. So WPCN consists of two different phases. The one is the downlink phase, another one is the uplink phase. The user send the information by using the harvest energy to the hybrid access point, so that is accessor HAP. So two different cognitive WPCN protocols depending on the cooperation level between the primary transmitter and the secondary HAP, so that is a hybrid access point. So here we using the interference leakage to the primary network into consideration. To tackle this issue, we first convert the problems into equal and convex forms like that, so and then identify the global optimal solution by applying the proposed iterative optimization algorithm for the particular HAP protocol. So finally the simulation results are compared with the output perform conventional scheme, so existing compared with the existing and output proposed scheme of the process. So finally calculating the two phases and then calculating the simulation result as per the particular protocol. Let us discuss about the flow diagram of the process. So these are the overall flow diagram of the particular process. So first of all, we initialize the system model. So in this system model, here we using the MIMO concept, so multiple input and multiple output process. So in the transmitter side, we have given the number of transmitters, and in the receiver also assign number of receiving transmitters. So hybrid access points is a HAP, called a HAP. Particular point will be node, like it is like an act as a node, and then initialize the parameters. So whatever it may be, the HAP and MIMO. So all the parameters it should be initialized, and then there are two types of one is the underlay and another one is the overlay parameter. So in the underlay process, here we are using the derive the optimization problem for the power allocation. Particular power it should be allocated. The optimization problem, the value which should be allocated for the overlay process also. So in case if the interference is less than the threshold value, if yes, the process will be continue for the optimization. If another way no, so maximum weight sum throughput will be calculated, and then finally performance analysis it will be evaluated by using the BER and SNR like that. So whatever it may be, the interference it should be minimum compared to the threshold value. So only the process it will be very efficient also. So the maximum weighted sum throughput of the process it should be high for comparing to the another process of the process. So the initialize the parameters underlay and overlay conditions, CPWCN and also a CPWCN. So finally whatever it may be, the optimization is must to proceed the way of approach, so threshold or any other like thing. So optimization is must, and then the scheduling processes should be follow the process. So maximize weight some throughput is throughput it should be always high because for the efficiency. So the maximize weighted sum throughput is must to calculating the process of the hybrid access point. So the MIMO concept is the MIMO it should be calculated the system model and then the initial parameters. So initialize the parameters, the concept of underlay and overlay of the concept, and then derive the optimization problem. Whatever may be a problem it will occur to derive the optimization problem for the power allocation, particular power to allocate to the underlay and also the overlay of the process. So if the interference is less than the threshold, there should be the maximize the weighted sum, otherwise the performance analysis should be low. So these are the overall flow diagram of the process. Let us discuss about the running procedure for the process. So click the main file and then run. So it has some time to run, and all the figures are displayed. So and then we describe a detailed description about one by one. Let us discuss about the k number of source nodes. So these are the k number of source node, and then this is a relay node and the destination node of the. So then relay node is converting the destination node of the process. So in the next figure, So in this figure, sum rates of MIMO BCs, that is subject to k equal to 10 and nt is equal to 2. So here we are using the sum rate and then GC. So sum rate, it should be high comparing to the proposed work. So then it's no energy trading of the process. So in this next figure, the same sum rate you will be calculating. So no RES, that's residual energy should be low of the process. And then the next figure, this is also the same sum rate. So the proposed no energy trading and no storage of the process. Here using the sum rate it should be always high comparing to the existing method of the process. So whatever it may be, the sum rate of the particular MIMO base stations, the value of the power constraint, it should be high, fluctuable rate and also throughput, it should be high for the underlay and overlay of the process. So in another figure, the same sum rate, so that is a MPBS, so megabits per second, so of the subject to E equal to K equal to 10 and NT equal to 10. So in this figure, the more or less the both are same. So the sum rate MPBS per seconds, MIMO BC as the NT and K is equal to 10 of the process. So there is no storage, no energy trading and proposed of the value. So and then sum rates of MIMO K equal to 10 of the process. So this is the optimal power scheduling optimum. So time slots 1, 2, 3 up to 8, the time slot between the P into time scheduling. So whatever the value should be high of the process. And then in this figure, the optimal power scheduling of the process, time slots and battery state. Battery state, in which time slot it should be high. So I here using the 3/3 time slot, it should be high of the battery state, kilowatts per hour. So these are the overall running procedure for the process.
Thank you for listening this video.